Hey, it's Alex Williams, the New Stack, here at KubeCon CloudNativeCon in Seattle, and I'm with the team from Oracle, Chad Uramura, of course, I can get that right, VP of Serverless at Oracle, Christopher Woods, Research Software Engineer at the University of Bristol. Hey, Christopher.
Hi.
And Sean Smith, Director of Product Management for Serverless at Oracle. Thanks for joining us.
Thanks, Alex.
Hello.
So, back in the day, way back, I'd say 10 years ago, I was writing about platform as a service. And there was Heroku, and then you saw services like .cloud emerge, and that was really the precursor to Docker, and we know what's happened really since then. Now we're seeing serverless has a similarity to platform as a service, but not quite the same. Maybe you could help us kind of draw some connections.
Yeah, I can start. So my name's Chad. Thanks for having me on the show. So it's funny you say that because my former company that I founded called Iron.io, our first product was something called Iron Worker, and that was inspired from Google App Engine, which was really like one of the first really well done platforms as a service.
Yeah, and there were some big scale out services that were built on Google App Engine.
Yeah, it was like 2006?
Yeah.
2008, 10 years old now.
Yeah. And we started looking at that, and we were super inspired by it. It had a lot of constraints that we didn't like, which was what inspired us to build what was then called Simple Worker, which is basically just zip up some code, send it to a platform, and then scale that out. So I think what's different now is that we're getting that same kind of realization of PaaS, but it's with less constraints. So now you can just ship containers, you have container contract, you can just ship zips of code, and it can scale sort of infinitely up to, infinite down to zero.
Yes, I can even go back further than 2008. So way back at the beginning of the 2000s, we were doing this thing called Grid. I don't know if you remember Grid. Was kind of like this idea that computing was just electricity, like electricity. You just plug it in and use. You don't think about where it is, and that's where you got all of this kind of grid certificates and kind of all the precursor technologies of cloud. And you kind of see now that Grid kind of had its time. It had its sort of peak of disillusionment from the Grid, and then kind of now it's. Cloud is Grid with a cost model, with a business model, so it's really cool. It's becoming real.
Is it really that? Is it really Grid with a service model? Do you see it that way?
I see it that way. It's basically compute on demand, data, disk, storage on demand, and you just don't think about where in the world it is.
So Sean, how's the consumption model changed?
Well, it's gone from you pay to deploy and run your service to on demand when it runs. So the PaaS would be, the Heroku model, right? You deploy your code, spins it up, it's sitting there listening on a port, you're paying 24/7 while it's running. It's shifted now to pay on the call. So if someone calls your service, you're paying for the service while it's running, and then when it's finished its job, you're not paying. So it's very much, it's like electricity, right? Turn on the light, it goes on, turn off the light, it goes off, right? You're not paying for it.
Right.
Yeah. It's a totally different economic model, right? It really changes the way people think about deploying their code. They can deploy if you're a small startup, you can deploy code and not be worrying about the fact that you got this huge bill for the service that no one's actually using yet. In the service model, you're going to pay if someone's using it. So it really gives a new opportunity for a lot of startups.
What is that? What do you think is that opportunity?
Well, they don't have that capital cost investment or even just the cost of the service. So it used to be capital cost was your problem. I have to buy a computer, spin up my stuff. Then it became I have to deploy my service to a cloud platform and pay for that thing sitting there doing nothing. Now it's I can deploy that at no risk to myself. If my service finds an audience, I'm going to pay. I'm going to earn some money.
Also, engineers are notoriously expensive, and every minute they spend on not building business logic, you're paying them to do something that's not strategic for the organization. And I think the big promise of serverless is that it can make your organization more agile, it can make you more flexible, it can make you move quicker, it can make you ship code faster to the cloud, not have to think about any of that kind of non-strategic, undifferentiated heavy lifting is what I've been hearing a lot of.
What does that mean?
You're going to make me say it again? Undifferentiated heavy lifting.
But what does that mean? Like a heavy lift.
Yeah.
That when it's. I understand the heavy lifting.
Yeah.
So when you're talking about it being undifferentiated.
The stuff that everybody has to do when you ship an app to the cloud, you have to choose a framework, you have to find a server, you have to provision that server, you have to get your SSH key, you have to log. These are kind of the old way of doing things. Maybe it's going to scale. Then what happens when that server goes down? You got to. All of this stuff is not strategic for the organization. There's no value to the business for spending time managing servers.
But you got to push that complexity somewhere else. So
Yes.
So where does that complexity go?
I think it's more in terms of the contract between the software designers sort of running on cloud native, then connecting through to the platform designers. Because effectively with serverless, what you're doing is you're saying, I'm going to define well-defined bits of work distributed by default. So you're basically making contracts with the stateless functions that they're distributed by default. And then you're saying, now I've got this application which can scale infinitely, in theory. It can then be passed over to the platform designers, and they then know we're agreeing on the same contract. They can then build something which will fulfill this sort of serverless contract of infinite scaling. But I think it's this key thing. The advantage is that you're designing for infinite scaling from the beginning. Because typically when you're building these platforms, I've done the times before, you build a new service and you design it to basically run on a small database and one server. You reach the point where you suddenly hit saturation of that equipment, and then you've got nowhere else to go. You've got to re-architect everything from scratch. You have this barrier to growth. Whereas this way, you're designing something which goes from 0 to infinite without you having to do any extra work. And I think that's the real promise of serverless.
Yeah, and also serverless is not just your code and your logic and your compute. It's things like artificial intelligence. It's things like image recognition. And those are services now that you can call through an API. That could be strategic to your organization, but like before, you know how hard it is to build, TensorFlow models and kind of manage all that yourself and have to set up infrastructure to do that. Now you can just call an API and get facial recognition right into your application just like that.
So Sean, what does that then take to build a product that suits the needs of these of these communities out there who are wanting to consume and build these new services? And I'm also then curious on how that has affected how you build your own teams internally.
Right. So we took this strategy with FN, the FN project, to do an open source. So it's great for a company to say we need to build a platform. But building it without customers, without a community helping drive that vision is difficult. How are you going to hit the mark? So we did the whole thing in open source, and as Chad was saying, the work began at Iron Functions. So when Chad and his team moved over to work on FN, we kept it in open source. We didn't close the door and say, great product, let's go build a cloud service. We kept it in the open source so that we could continue to have that community input. So we're getting input from people like Christopher, who are really pushing the limits on the scale that you can push it to. So the challenge for us now then for building the cloud service was taking that open source core, that base, and making it highly available, highly scalable, reliable, right? That's what you really want from a cloud service. So a FaaS or a functions platform isn't necessarily a cloud service, right? It's just you can run it local.
Right.
So there's quite a difference for us. We're spending a lot of energy in that, the engineering of making it cloud scale, reliable, and so on, right? That's where a lot of engineering is going to that work now.
So Christopher, tell us then about what is required of you to adopt serverless, this serverless approach, and I like it with FN.
So we've always kind of wanted to do serverless approaches, but the thing that's always held us back is that the function services that are out there are not open source. They're kind of vendor lock-in, very difficult to work with, and that meant if we invested engineering effort, we kind of tie ourselves to one platform.
What problems did that pose? Were you increasingly becoming open source, and then you needed to have that compatibility?
So I work at university. Everything we do in the UK is open source. So particularly in research, we always basically produce open source software, and we don't want to tie a solution down to an individual platform. So it's kind of like there's this push where we wanted to go serverless, we wanted to particularly go functions as a service, but Lambda, etc., we didn't want to be tied into one thing. So it's waiting for an open source solution to come along which would actually be supported by a big cloud. So FM was kind of like almost God sent to us. It was great.
Mm-hmm. Good to hear.
And so do you run it on-prem, or do you run it through how are you running FN?
So we're running FN actually on the clouds, most of the clouds at the moment. So I have FN running on the Oracle Cloud, on Google Cloud, on Azure Cloud.
Okay.
The nice thing is it's a Helm chart. It installs on Kubernetes. It's all very standard. The community behind it are great. So, I have problems, go on Slack, send an email, issue on GitHub. Everything is completely open. And it means that I know exactly what's going on underneath in terms of the code and how it's working. So I can then build my workflow to match its model as well.
And it's an awesome use case too. You should talk about it.
Yeah, let's hear it.
So the use case is basically I'm building things for helping researchers do research workloads. So essentially we're running simulations, we're running data analysis. So effectively you have these things called Jupyter Notebooks. And the problem with Jupyter Notebooks is you're running on the sort of hardware that's running the notebook. So in a Kubernetes cluster, it's all on that one notebook, or on that one piece of hardware for the Kubernetes cluster. What FN's allowing us to do is actually burst out from the notebooks onto sort of HPC hardware, so your bare metal, large, expensive cloud instances, and only use them to run the simulations you need. So one thing we've architected for implementation next year is essentially we have loads of satellite data, atmospheric data. All of that data will be basically piped in via FN functions into an object store, have simulations then tracking, say, methane emissions, and we can then backtrack methane to target the individual cows and then work out how many cows there are in the UK contributing to the UK's greenhouse emissions. So it's this distributed thing that has to scale.
Did you say cows?
Cows, yeah.
What about the cows?
We have to count the cows.
Why?
Because every country with the Paris Treaty actually has to say how many polluting things we've got, and cows are massively polluting. We need to know how many there are. And this will help us, not just cows, but also cars, factories, and it will basically take all of these sensors, all of the satellite data, and feed it in a distributed way into a global object store, and then enable scientists to use Jupyter Notebooks to then analyze it, produce reports. We can publish web portals which will show out to the public and enable them to actually look at kind of the pollution that's been generated. And equally, we're doing sort of things for companies as well, so they can say, we've invested in this pollution reduction thing, can we actually see, is it really worth its money? So it's really kind of, FN for us is part of this sort of cloud native stack, which is enabling us to build these kind of global distributed applications, what I like to call the planetary supercomputer.
So Chad, tell us about the architecture of the stack itself, in how you built it, and now how you're using it as a distributed architecture platform across multiple cloud services.
Yeah, I mean, there's a couple of different elements. FN itself is the functions as a service platform. It's built to be independent of Kubernetes, but we have a bunch of Kubernetes native stuff like Helm charts to deploy it to Kubernetes clusters, so that you can rely on Kubernetes substrate to handle all of the orchestration and kind of infrastructure management. And then obviously it's got a really nice developer interface through our CLI and our API. And it's also container native, so anything that can be a Docker container can be your function, which is slightly different than some of the other models that we've seen. We believe.
Why'd you take that route?
Yeah, I mean, when Docker came out in 14 or 15, we looked at it and we said, this is an incredible contract. I mean, it's such an amazing developer experience to be able to.
Were you using LXC before that?
We were.
Yeah.
Good memory.
Yeah.
We rewrote everything to support Docker at Iron, and we brought that over because, if you've ever tried to get software to work, you have all these dependencies. Like try ImageMagick, for example. There's so many dependencies you have to get to work on every different environment. But then at the very end of like the page, you'll see, use this Docker file, and you just boom, it's run, and you're in, and everything works fine. And we believe that should be the contract for how you build functions. So we sort of meld the simplicity of serverless with the power of containers, is what we say.
I mean, I completely agree with this. So it's basically the fact we have a Docker container. I can put anything I want in that Docker container. So I put in simulation codes, huge packages. It's not just like a little toy Python or Node.js example. We're talking about here complete stack of software. And because it's the Docker container, effectively the contract is anything that comes in as standard input has been passed in as the input of the function. I can then do whatever I want with it in any language I want. Everything I write to standard error goes to logs. Everything standard output is the output for the function. We tend to serialize with JSON because it's easy, but that fundamental basic contract is exactly what you need to build really complicated applications. And I think if you compare it to, say, Lambda, where you basically upload a zip file, you don't really have that much control of the software. I think that's the wrong model. That's simplifying it too much. Docker container is the right way to build serverless functions.
I was going to say, so my experience in the past was working on cloud native, like Heroku-like platforms, and it had this trade-off between productivity and power. So you could easily deploy a piece of code, they wrap it in a container or LXC, they deploy it, great. But I had customers who would want to install packages, and then what do you do, right? So the Docker container gives us that basic building block we're all familiar with to customize to our heart's content, right? To do complicated things. So for FM, we like to say that easy things are easy, but you can do difficult things because of the Docker platform.
And I would say the FN CLI is brilliant. I mean, literally, once you've got your Docker file, it's sort of just FN build, FN deploy, and everything just builds. So I've got like little build scripts now. They're literally just lots of FN build, FN deploys, and it's really easy to use. It's something which I've been able to give to my researchers and the people in my group and say, now you can build serverless functions easily. They don't have to think of it. It's not like 10 years ago where it was really hard work.
And it works independently of Kubernetes?
It does, yeah. So you can deploy it off Kubernetes, but we use a lot of the Kubernetes power of Kubernetes to use a Helm chart to install it and have Kubernetes kind of manage it all for you. So we make it a really nice experience, and we're currently evaluating different paths to make it more Kubernetes native. So, for example, use like CRDs, for example, custom resource definitions, to be able to declare your functions in Kubernetes. But we're sort of evaluating what that looks like.
Sean, how are you evaluating? What are you exploring now?
For the Kubernetes? Well, the question for us is, what do you want to run prem, right? Or what is the stack? So we've had Linux for years, like that's our basic stack. Now the question is Kubernetes the de facto like stack, next level of the stack? If that's the platform we build on, then if everyone's got it, if it's a common infrastructure, then it makes sense to leverage it. When we began FN, we were not willing to make that bet yet. And so we basically hedging our bets. So at this point, it's evaluating the market, where it's going, and if it makes sense to embrace and then take advantage of some of the features we can get from the platform. But right now, it's quite nice thing. Part about FN is it's small, independent.
What are you waiting for?
Download it. Good question.
Well, there were some challenges. Like Kubernetes, it wasn't necessarily designed to spin up, 1 million 2-second functions or 300 millisecond functions. It's more for like managing containers to run long running.
Right.
It's getting better and better at different types of workloads. So we're, as it becomes better, we'll look at it to handle that kind of stuff as well.
So I want to have functions which spin up in a millisecond. So with the fast ones, I actually run the native FN server. And so with the native FN server, again, I can run on my laptop, I run on VMs on the cloud, and with that I have functions going in about 2 millisecond startup time, and then they'll run for a millisecond or 2 milliseconds, and I need that kind of speed for all of the management work that's going on behind the scenes for the platforms we build.
The last thing I was going to say is, but for us, the most important thing is developer experience. So maintaining a great API, maintaining a great CLI experience, and what happens under the hood shouldn't really matter. If we leverage the power of Kubernetes to make it easier for our customers to operate, great. If not, at least that we want to maintain that developer experience. It's the most important thing, because serverless is the interface to developers. Everything else is like undifferentiated heavy lifting.
Well done.
Nice.
I got it out that time.
Nice job. So, with Kubernetes, what do you see as I guess the question still is, what are you waiting for in terms of like how Kubernetes builds out to make it something that has that capabilities that, like, for instance, data scientists might want, right? Where you have that kind of millisecond kind of capability.
The reality is that developers there's a lot of, look at this conference, there's 8,000 people here and many vendors, and so there's a lot of great ecosystem partners that are building great application development platforms on top of Kubernetes. So more and more applications are going to be cloud native on top of Kubernetes, and those have to talk to serverless applications just like any other construct. And so these things all need to happen. They could happen within the Kubernetes networking model, and so that's something that we're going to be evaluating pretty closely. You may use Kubernetes secrets to do secrets inside your functions. These are all the kind of things we could take advantage of.
But Chris, you also do use Kubernetes. We had you as a guest on our pancake breakfast the other day.
Yes, I use Kubernetes. So basically, we use Kubernetes as the underlying sort of stack for Jupyter Hub. So to run our Jupyter notebooks, effectively every time someone starts a new notebook, Kubernetes is underneath provisioning a pod with a new notebook in it. I think it's the ability to split the notebooks running on kind of VMs, that's what Kubernetes is very good at running, from being able to launch functions which could be running on big clusters or big, heavy, expensive hardware that you only want up when you're running that code.
Sean, is that an approach you're seeing?
The split?
The way what Christopher is describing?
Yeah, that's what we're saying. That's what Chad was saying. So you have your longer running, heavier workloads, and then we have functions which are much lighter, going to come and go. So Kubernetes is good for the performer right now, but we're still seeing this split.
And so, what are the other customers saying about this? Are they, what are they looking for?
At this point, I don't think all of our customers know exactly what they're looking for.
Yeah, that's true.
That's the problem. And even just now we're at let's talk about details like Kubernetes and functions. Let's talk about cloud. A lot of customers still aren't on the cloud. So, we expect a lot if we think the customers are going to tell us, I need for it to be like this. At this point, we're working with the community again, getting practical experience with people trying these things out to help guide what we actually deliver as a product.
What's that practical experience that that you're seeing people? What does that practical experience mean for the customers? Is it just trying to find the right fit with their resources to see what they should be considering for how to make into these serverless type environments?
On the resources side, I mean, the problem we have there is a gap in terms of the expertise of the developers we're dealing with. A lot of corporate developers don't have the expertise to say, yeah, I'm a Kubernetes developer, let's go. We're not there. So again, I'm going to keep going back to the market's not that mature.
Yeah.
Honestly, and we're kind of on the edge. Pushing or building a function service on the cloud is like as bleeding edge as I can probably get.
Yeah, and we talked about this on the panel yesterday.
Yeah.
Was that yesterday?
Yeah, it was.
Where you really need that champion internally to go in and say, this is the way it's going to be done, and kind of communicate these best practices to the rest of the organization. It's always that one or two champions with an organization that start to spread it like wildfire internally, and yeah, without that, it's hard. It's a big cultural change to move in this direction.
And so what you're seeing with that then is this early emergence, but with that early emergence, then that means investment on your part, right, into these different communities, doesn't it?
Yeah, in external communities too. And what's interesting was, in terms of the adoption, is internally, I'm seeing internal Oracle teams really excited about functions. They can see a million uses for functions to extend their services. So there's a lot of services that have some kind of elastic compute component where a little bit of computing has to be done, or it's part of a workflow, there's some user-definable behavior. There's a huge demand internal. So it's interesting to see what the internal demand is, which is still, in fact, they're actually probably even more demanding than the customers at this point.
So you must be do they think of what you offer as a platform?
They're thinking of us as layered services. So functions become just another layer, and this is what we think the way the world is, right? So you got compute, containers, functions, just part of the stack. It's nothing. It's just another piece of the toolbox.
Yeah, we have lots of internal customers that have taken the open source project and gone and launched it on their own to do their own workloads.
Yeah.
But the big announcement here at KubeCon is that Oracle announced Oracle Functions, which is our managed service based off the FN project.
I want to hear about that.
Sean's the expert here. He's the lead PM, but we made a big announcement.
I was alluding to earlier that FN, the open source, is a solid core, and then the goal for us when building Oracle Functions is taking that and making it a managed, highly available cloud service that can take advantage of the cloud. So again, we've got a huge cloud, we've got compute, it's elastic, we want to be able to let customers get at that on demand. So that's what we're building, and we've announced today, or yesterday, that we have a limited availability program. Customers can sign up to try it out, and that along with some other services that have been announced.
How is it a next step then for what you've already developed, what you launched this week?
Next step, and what do you mean?
I mean, how does it kind of tell your story and how your story is progressing?
So we had gone from the open source story, building FN. We'd gone then to building this cloud service. We've been in internal limited availability for a while, so letting internal teams kick the tires, try it out, hammer on the service. Now it's ready for customers. So now we're confident enough with what we've built that we're allowing customers to give it a try.
Yeah, and at Open World, I mean, not to talk all about Oracle, but we had something called Oracle Linux Cloud Native Edition,
right.
And what that did is package a number of the CNCF open source projects into Oracle Linux and make that a supported offering from Oracle. So you see, what does that journey look like for Oracle? Well, we're platinum members of the CNCF. We find this community to be extremely important for the future of Oracle as well. So they brought our team on from Iron. We've been doing a lot of things open source first, and the work that the Oracle Functions team is doing for the managed service. That knowledge of building a scalable service goes back into the open source project, which then gets released to the community. So it's this kind of feedback loop.
It goes both ways. So we're getting requirements from the community on what it needs to do, and then hardening efforts that they're going into it to build an actual cloud service are flowing back into the core. So it's a nice loop.
I mean, ultimately, it's that story from basically open source piece of software through to managed service. You kind of see this happening now with Kubernetes, where essentially we're moving from people spinning up their own clusters to every cloud vendor offering a managed Kubernetes service, because ultimately we don't want to be managing Kubernetes services ourselves. At the moment, I'm obviously managing FN on different clouds because I have to. There isn't any other way around it at the moment.
It's nice to see that, though. I like to see,
And ultimately, I think, what we're kind of waiting for in the sort of the function space is for when you get managed function services, which are ubiquitous. So it's the same functions platform, but you can choose different managed services, different clouds actually offering it. At the moment, if I want to use FN, I'll eventually be able to use the Oracle FN service, or I manage Kubernetes on Google or Azure, and then I sort of put it on top of that. But I'd hope that we'd move away from clouds offering their proprietary functions, and instead the community evolves the one, like Kubernetes, we have the one sort of open source function service, and I personally think as the container model, it's all based on Docker, standard in, standard out, standard error is the right model for developers. I'm kind of hoping it's FN.
Okay. Well, so when you're thinking, what are some of the internal use cases that you're seeing that are helping you think through, what FN provides?
So things like if you're building a mobile backend as a service, those kind of use cases are you're defining APIs, you're defining some logic behind the scenes, it'll probably talk to your backend services. That's a perfect use case for serverless because customers are using a mobile app, they hit a button, they do something, it invokes some functionality. That mobile backend service, people were building those platforms didn't have serverless. They were building managed compute farms that were limited in scale or manually scaled. So those kind of use cases, anytime you have user-definable code that runs on demand, these other teams can now stop managing their own compute and just basically farm it out. Just make it serverless.
And data processing is really, really popular. I mean, Christopher's been talking about their use case doing interplanetary space data, but anything from like image processing to video encoding to IoT device streams to chatbots, yeah, all sorts of sort of data processing. It's very parallelizable. It's very asynchronous. It works really nicely with the sort of characteristics of serverless. So
what are you seeing what are you seeing in terms of the team development that is happening with the adoption of FN internally? Are there teams changing?
The team's changing, yeah. So I've been at Oracle a while, so I've seen quite a change. We have people, Chad laughs, but because he has some interesting guys in his team that he brought with him. But these are really interesting people with new skill sets. So there's new skill sets. People are having to learn new skills and evolve, right? The world is changing. This is
what
not...
What are those skill sets that...
Well, I think Go as a language for development is taking off quite a bit.
Right.
Certainly within Oracle and elsewhere. Go, obviously Docker, Kubernetes, all the things we're talking about are becoming the standard tool sets you have to know.
Yeah, and we talked about this again on the panel yesterday, but I think one skill set that's becoming important is both communication and a sense of ownership, because we're focused more on delivering services and delivering value. A single developer or a single small team of developers can own an entire stack from top to bottom because they don't have to worry about 90% of the stack anymore. And so this sense of ownership, of uptime, of all that, we're seeing that more and more. And the ability to communicate and document that to other people as well, to sort of champion these architectures internally, is really important.
And so when you're so the teams that are starting to change a little bit, how much of it is operations focused?
We're doing a DevOps approach where the people, if you build it, you own it, right? So that has changed the day-to-day. Like it is operations and development. Those guys are carrying pagers. It's the full life cycle. So that's changed. A lot of developers in the past, it would have been build the code, hand it off to operations, they deploy it. There's a problem, it goes to sustaining engineering. Like it's just old school stuff. That's not happening anymore. That's completely changed. So all the new things we're building are built in a much more contemporary, modern DevOps.
Yeah, and operations is changing too. I mean, this is not a no-ops world. It's just, I called it a diff-ops world, I guess. At one point I said that. And it's just, we're not worrying about how to patch a server or whether it's going to go down. We're thinking about, well, first of all, what does my data model look like? And is my database scale? And can I use a serverless database type of solution? Or what... how do I scale my application, and what does that actual scale pattern look like, and what does the architecture look like across the entire application? That's kind of all changing now.
So you must be looking for people who are developers but also have an interest in operations, then? Or they're interested in operations but they're starting to understand that cloud native architectures require to have some understanding of these technologies that developers also use?
Yeah.
Yeah, I mean, I think they have to, again, like a sense of ownership. There's no longer a world where you can write some code, throw it over a wall, and then your job is done, you go home.
Right. Which seems like natural just to a lot of people who have been in this world for a while. But, one of the things that we notice is there's this learning curve that can actually span kind of multiple generations of developers and people in operations, right? There may be someone right in college, for instance. You're talking about students at Bristol who may be just absorbing this for the first time and building it. But then there's groups of people in operations who've been in there 10, 20 years who are looking at new approaches and how they're having to build.
Absolutely.
Yeah.
Yeah, I mean, it's actually kind of ironic because operations roles are actually some of the lowest hanging fruit groups to start using things like functions as a service, because you can do really, really cool automation stuff that you couldn't do before, that you had to like stand up a server and install cron and have it, do this and that. Now you can just like create a function, deploy it to the cloud, and you can manage all of your infrastructure using functions. And so operations or DevOps is pretty low hanging fruit. So we're kind of seeing this big merge of, developer and operations into DevOps.
Yeah. Right. Well, this has really been an interesting discussion about how teams internally have to think about about their own services and how they can make them, I guess, more streamlined and more declarative and being able to then operate in this cloud native world. I guess one of the questions I have is like, how does that affect kind of your own internal thinking about open source and how you need to think about and how teams internally, for instance, at Oracle, are thinking about open source technologies, because a lot of those open source technologies are kind of what you're talking about. These tools and platforms that are built out in the community.
I think ultimately it comes down to commoditization. So essentially, if there's a part of the stack where you're not really adding value as a business, it's not really critical for you, then ultimately open source it, have a community develop it, share it between everybody else. And I think what we see is this stack is always moving upwards. And ultimately, when Linux first came out, 20, 30 years ago now, essentially it just wiped out the operating system level of the stack. Containers from now basically, so there's no point really building other container platforms because that's gone, all share that. And I think ultimately for businesses and for research as well, to be successful, we need to be concentrating our brain power, our efforts on the top, and then commoditize and open source everything below.
That really is the model, isn't it? Thinking about the business objectives and then who's on your teams and the workflows and what are the technologies that really fit with those people and those business objectives.
I mean, you couldn't imagine with Kubernetes actually having so many people contributing it if it was a closed source project, if Google kept it in-house. As soon as you open source and you get that momentum behind a project, it just explodes. And that's why I think it was brave, I think, for Oracle to do this with FN, but I think it should be rewarded, and hopefully people will sort of jump on and throw more things into it. And I hope they're overwhelmed with pull requests.
Me too.
Well, thank you so much for your time. I appreciate it. Look forward to kind of seeing how the platform continues to evolve into 2019. It is such early days, really, and but here you are. So congratulations on your launch, and look forward to keeping in touch.
Thank you.
Thanks, Alex.
Thank you.